If the mth term of an AP is 1 on n and the nth term is 1 on m, show that the sum of mn terms is half of mn plus 1. In this question, we have given mth term of an AP as 1 on n and nth term of an AP as 1 on m, and we need to show sum of mn terms is half of mn plus 1. So we do not have any first term and common difference for this AP. So let's say the first term of an AP is A and common difference of this AP is D. To write down mth and nth term, let's learn how to represent any term in an AP in general form. So, an is equal to a plus n minus 1 times d. Now, as we have given mth term, so let's write mth term, which is represented by a of m. So, am is equal to a plus m minus 1 d, which is equal to 1 on n, as it is given to us. So, let's mark this equation as 1. Now, similarly, let's write down nth term. An is equal to a plus n minus 1 times d, which is equal to 1 on m. And let's mark this equation as equation number 2. Now, we need to find out the value of this first term a and the common difference d. For that, let's subtract these two equations. Let's say equation number 2 minus equation number 1. For that, let's write down equation 2 first of all. A plus n minus 1 times d is equal to 1 on m, and a plus m minus 1 times d is equal to 1 on n. On subtracting, we know we have to change the signs of the expression which is being subtracted. So, let's make it minus, minus and minus. By this, we can cancel out a. So, once a get cancelled out and we are left with n minus 1 times d minus m minus 1 times d equal 1 on m minus 1 on n. Now, let's simplify this to find out the common difference d. We get nd minus d minus md plus d equal, let's take out the common denominator, mn, and it is n minus m. Here, we can see d get cancelled out and we are left with d inside n minus m equal n minus m over mn. So, we can find out the value of d now. D is equal to n minus m over mn multiplied by 1 over n minus m, which is equal to 1 on mn. So, this is the value of d for this particular arithmetic progression. Now, using the value of d, we can calculate the value of a by substituting this value of d in any of the equation, either in 1 or 2. So, let's substitute the value of d as 1 on mn in equation number 1. Am is equal to a plus m minus 1 d equal 1 on n. Let's put d equal 1 on mn and we get a plus m minus 1 times 1 on mn equal 1 on n. Let's simplify this to get the value of a. A plus, we open the parenthesis, m times 1 on mn gives 1 on n minus 1 times 1 on mn gives 1 on mn equal 1 on n. then A equal 1 on n minus 1 on n plus 1 on mn. Here we can cancel out 1 on n and 1 on n, and we have A equal 1 on mn. So, A is equal to D is equal to 1 on mn. Now we have the two major values, the first term as well as the common difference of this arithmetic progression, with which we can show that sum of mn terms is equal to half times mn plus 1. So before moving on, let's write down the formula for sum of n terms of an AP. Sn is equal to n on 2 within parenthesis 2a plus n minus 1 times D. Now here we need to find out the sum of mn terms. So let's replace n by mn. So S of mn is equal to mn on 2 times 2 times, in place of a we'll write 1 on mn, plus in place of n we'll write mn minus 1 times, in place of d we'll write 1 on mn, and close the bracket. Now we need to simplify this. So we get mn on 2, 2 on mn, plus, now open the parenthesis, we get mn times 1 on mn is 1, minus 1 times 1 on mn is 1 on mn. Now these two terms are like terms. So on solving them, we get mn on 2 times 1 on mn plus 1. Now inside we can find the common denominator, and we get mn on 2 times 1 plus mn over mn. And here this mn can be cancelled out, and we are left with sum of mn terms is equal to half times mn plus 1, and hence proved.